Here was the problem we just did with the two parametric equations. Now, when you're asked to go from parametric equation to rectangular equation, we first have to understand what that means. A rectangular equation is an equation with x's and y's. And our method for that, given as a straightforward algebraic equation, will be twofold. First, we're going to solve for t, and then we're going to substitute for t. So those are the two rules you must know. We're going to solve for t, and then we're going to substitute for t. Well, where should we solve for t? Wherever is easiest. This equation, y equals t plus 1, indicates to us that t is equal to y minus 1. All I've done here is subtract 1 from each side. Hopefully, and I know they are, your algebra skills are strong. If I solve for t in the second equation, I'll go to the first equation, which is with x, and substitute for t. I know x is equal to something squared plus 2 times something. Now, it was t, but t is equal to y minus 1, which means anytime I see where t was, I can replace that with y minus 1, and y minus 1. Now, if you want to, you can stop right there. We've done our job. Makne date, as we say in Tetun. That's it. That's all it is. It's a rectangular equation. But I can't stop until I know what this looks like. So I'm going to keep picking away at it. I understand that y minus 1 squared is y minus 1 times y minus 1, and that I can distribute this out to give us plus 2y minus 2. Now, if I FOIL this, first outer inner last, I get y squared minus y is minus 2y. Negative 1 times negative 1 is plus 1, plus 2y minus 2. I recognize I have negative 2y and positive 2y. If they've been good little 2y's, they go off to number heaven. And I'm left with x is equal to y squared plus 1 minus 2 is minus 1, which I can manipulate, maybe strangely at first, into y squared equals x minus 1, which implies y minus 0 squared equals 1 times x minus 1. What? Why did I do it like that? Because I know from my study of parabolas that we had this form, y minus k squared is equal to 4p times x minus h. And if I write it like this, I can tell you that hk is, start with the x, was that negative 1? I'm sorry, I want to add 1 to both sides. Sorry, my bad. If I add 1 to both sides, I'll get negative 1 for h and 0 for k. I know that 4p is equal to 1, so p is positive 1/4. Because y is squared, I know it opens left or right, and because p is positive, I can now confirm it opens to the right with a center at negative 1, 0. Ah, look what I have here. A vertex, negative 1, 0. If I go 1/4 to the right, there is my vertex at negative 3/4, 0. And doubling p would be 1/2. So if I go over p, I go up to p and down to p. What a great problem. It reviews our knowledge of parabolas, which is a conic section from our past, and FOIL, and this idea of solving two equations in two variables. Remember, to write from the parametric equation to write the rectangular equation, you're looking for an equation in x and y. We're going to follow two rules. Solve for t, and then substitute for t.